Greetings! In this video I will show you how to check an LED if it's working in your gadget gizmo that you might have, or how not to check it if it's working in your gadget gizmo thing. Sometimes you might have a piece of something, a flashlight for example, and it's a LED flashlight and you press a button and nothing happens. Well, this one's working, but yeah, it's not lighting up. So what you're going to check, you're going to pull out a multimeter and check the voltage across the battery. Yeah, the battery is good. Then you're going to check the switch. Yeah, the switch is good. Then you're going to check the continuity on the LED, and it's showing infinite resistance, and ooh, you think the LED is busted. That is not the case. So let me show you a quick and dirty way to check a few LEDs, even if you haven't got a multimeter. It's a really simple way, and also a common mistake that happens when you're trying to measure an LED, because it's a little bit counterintuitive, but an LED, a diode, is not non-linear element. So let me maybe first explain what that means. So here we have two little charts on which we'll try to compare a diode, a non-linear element, to a linear element like a resistor or a light bulb. So let's do this one first. So this will be a resistor or resistive load, a light bulb, a linear element. So with those, the current flowing, which is going to be over here, and those are arbitrary values, it's just 1, 2, 3, it's not what exactly happens, but you'll be able to see how to illustrate it. So with those, let's say you've got 1 volt and you've got 1 ohm of resistance, you'll get 1 amp of current. So this will be the point. And you increase the voltage with 2 volts, you'll get 2 amps of current. So like so. And this will be the point. And with 3 volts, you will get 3 amps of current. And what you get is a straight line, and that will keep going to infinity, omitting the power dissipation and whatnot. This is why they're called linear elements. So the voltage to current ratio is linear, is a line on a chart like this. It doesn't matter how you arrange the actual values. That's what it's going to be. Let's have a look at a diode. I'm gonna draw a diode symbol over here, and non-linear. So this is where it gets a little bit tricky and a little bit interesting. So a typical diode has got a forward voltage of 0.7 volts. That's a typical rectifier diode. Some of them will be higher. A Schottky diode can go as little as 0.2 volts, a really good one, usually 0.4, 0.5 and so on. You will have LEDs. LEDs are quite a bit higher, so they can go 1.2 volts for an LED, a low power one, to as much as 60 volts for like a 100 watt LED chip, a big one. So what that forward voltage means, if you are below that voltage, so for the purpose of this example, let's assume that the diode has got a forward voltage. We're going to consider 1.5 volts forward voltage. So what happens with a diode like that when you apply volts to it? Well, when there is no volts, there is no amps, so no current will be flowing. All so far very simple. Now going forward, when we increase the voltage, let's say we've got 1 volt, okay, because this is below 1.5, it's not enough to overcome the barrier in the diode. It hasn't started conducting yet, so it's still no current, so it stays at this level. And that's for an ideal element. Of course, in a non-ideal element there will be a tiny bit of leakage current, and for the purpose of explanation we can assume that there is no current happening, so still nothing. We go to 1.3 volts, which will be about here, 1.3, and it's still below 1.5, still nothing happening. So over here we've got still 0 amps. 1.4, still nothing. 1.5, so 1.5, the diode will start conducting. So you'll start getting a little bit of current. So it just picks up from the ground, from the 0 line. And when you get to 2 volts, the current is gonna start flowing quite significant, maybe even 2 amps. And when you go to 3 volts, the current shoots through the roof. So the chart will be looking somewhat like this. Well, it should be somewhere here, quite up high. So mind you, there shouldn't be a bump over here. It's just not a nice straight line, but this is basically the diode, how it conducts currents. And because of this, when you're trying to measure an LED, you'll put sometimes you'll put a multimeter across it on ohms range, and it's showing infinite range. So let me show you what I mean. Here I have a typical multimeter, and I've got a couple of 4 typical diodes. 2 of those over here are very old school, old technology diodes, and those 2 are quite modern. This is a 1 watt LED, and this is just a standard 4 meter LED, a flat top. So with let's try to measure them. So we are on ohms range, and we're showing 0L mega ohms, so yeah, beyond the range. So let's try touch on a diode. I've touched the probes for a second. No, we get nothing. Let's flip the diode around. Still nothing. So is the diode busted? Let's see. Let's try the next one. So nothing. Nothing. This one's busted too. Let's try this one. Nothing. Nothing. And this one as well. Nothing. And we flip it around because our diode, whoopsies, I lost it. Diode conducts only one way. It shouldn't conduct at all in the other direction. Up onto a point of breakdown voltage where basically it self-destructs. But yeah, we got nothing, and if we flip it, still nothing. So on the multimeter you have an option, most of them, there is an option to change it to a diode mode. So let's see what we get with that diode mode. This way we get 1.8 volt, and this multimeter, what it's doing, it's actually showing us the 4 volt voltage of that diode. So this is what that diode drops, 1.18 volts. Okay, the next one, nothing this way. Let's flip it around. Okay, this one is 1.791 volts forward voltage. Okay, we're getting something. This 1 watt LED, okay, it's still showing over well, it's showing over range, overload, 0L on the display, but the LED lights up. So what's happening here? And this one lights up as well. It's a blue LED, but yeah, the multimeter is not showing anything. So why is this happening? So first of all, you can't measure a diode with ohms range. That shouldn't be happening. This will never get you the right result. Sometimes with some combination of multimeter and something else and the diode, it may show you some nonsense value, but it doesn't mean anything. Sometimes you may even light up the LED, depending on the multimeter. They use different voltages. But what happens when you switch over to the diode range, the meter knows that you're going to try to measure a diode, so it puts a little bit higher voltage on the terminals because it's expecting that 0.7, 1.2 volts drop, and typically the multimeter will show up to maybe about 2 volts voltage drop on a diode. Anything more than that, it will show 0L or overload, and yeah, they are designed to check rectifier diodes and so on and so forth. You can't be checking diodes that have got higher voltage than typically 1.8 to 2 volts. That's pretty much most of the multimeters top out. So how do you check them if you have multimeter? On the diodes range, as you could see over here, this one lights up. Even though it's not showing anything, that tells you that the LED is good, because it's the voltage drop. The multimeter is probably putting out up around 3 volts or so, very low current, very low voltage out on the terminals, and that's why this LED starts conducting, and that's safe. It will show up, but again, because it's a high power LED, it will not show up anything on the multimeter, because it's beyond what it was designed for. So those two over here, I'm not sure if you can see that, but those actually light up too, very dimly. Those are very old LEDs, old technology, so they are not very efficient. In fact, they're horrible, but yeah, it does light up. I'm not sure if you'll be able to see this. Yeah, it kind of shows on the camera a little bit. It does light up, and this green one too. If we it's a little bit less visible on the multimeter, but trust me, it does light up, but extremely dimly. So because those have got a voltage drop relatively low, those will show up on the multimeter, and the multimeter is meant to show mainly, as I said, low voltage drop diodes like rectifier diodes, for example, or Schottky diodes, to check them if they're working, if they're broken, if they conduct both directions. That's the idea behind it, but it's not meant for LEDs. So how to quickly check an LED? Well, for as long as your LED is a low power LED, say under a watt, maybe even under 3 watts, you could do this trick with. It's really simple, because what's the special property that differentiates LED from a rectifier diode, for example? Well, it emits light, so it will show you that it's working as long as you put some current through it. Now the danger is, if you go over here with too much current, and I'll show you that in a moment, if you go beyond that, much beyond that forward voltage, you'll start putting quite a lot of current through the LED, sometimes as much as your power supply is capable. That will kill your LED instantly. It will just, if your LED was good, it's not good anymore, so you might as well assume it's good and not measure anything. But if you want to just check whether the LED is working, this is the simplest thing you could do. A 3 volt button cell battery with just couple of wires attached to it. Now, if your LED is not soldered yet, you don't even need the wires attached to it. You can just put the LED across the battery, the 3 volt battery, and you can see it lights up. So yeah, it's a good LED, it's working. As I said, they're all not very efficient, but it is working. And the same thing with this one over here. It lights up, it's fine. So okay, let's move on to the next one. This one, that's a new style blue LED, quite a bit more efficient. They produce a lot more light, and yeah, it's working. And the beauty of using this is those batteries have got quite a bit of internal resistance, which dampens down this effect, and it will not kill your LED. It's 3 volts with quite high resistance. It will be safe. It only puts, in this way, it will put out a few milliamps or so it will not damage it. If you've got a short leaded LED like this 1 watt LED, or your LED is soldered on, you can put, not this way, and there you go, it lights up, so we know the LED is working. You can also test an LED in the circuit without too much trouble actually with this. Like in this flashlight, we've got an LED over here, and let's say that flashlight was giving me trouble and I want to quickly test it. What's the quickest way to do it? Well, put this across it. One way, no, the other way, there you go. the LED is fine. It's absolutely fine. So this is a really quick and easy, it's a dirty trick just to basically check whether it's okay or not okay. If it's not lighting up with the battery, it might be that it requires actually higher voltage. You could actually try 2 of those batteries in series, but this is very unlikely that you will have a LED that's such a high voltage, and normally this will do the trick. Even if it makes it light up very dimly, you'll be able to see that yes, the LED is fine. Here is another way to test it. I've got a component tester over here with a custom-made box, and let's put an LED over here and see what it will tell you. See, as it does testing, the LED will put a few blinks, and there we go. It's a 1.93 volts forward UF voltage and 30 picofarads capacitance. So yeah, capacitance is another parameter of diodes. The junction actually has got a capacitance to it, which starts to give you problems if you're into very high frequency stuff. And let's check this one. Yeah, it gives a few blinks because it does it testing. 1.99 volts, slightly off from the multimeter measurements, but it doesn't matter, I guess. One of them is wrong. Next one here, 2.88 volts. So you see, this is a new one, the blue one, and it's got quite a lot higher forward voltage, 2.88 volts. Now this will actually show you higher, even more than that, whether your LED is working. So you can see that it's gone over that 2 volts barrier, and the multimeter was showing over the range symbol over there. Let's try this one now. I can't bend this one in like that, so let me improvise a little bit. Okay, let's try. So I'm going to put LED over here, and I'm going to stick some copper wire here and hold it like that and press the button, and let's see what happens. Yeah, it gives a few blinks, and we've got 2.6, 2 volts and 0.39 nanofarads, so 390 picofarads capacitance. And yeah, the LEDs are fine, they are working, and that's how you can measure them using just a simple button. So if you haven't got one, just put 2 AA batteries in series, that will do just fine. Just mind you, the AA battery has got quite a lot lower internal resistance, so with some small LEDs you can actually damage them by using 2 AA's. Now you might be tempted to use something a little bit higher, let's say 9 volts if your battery if your LED is not working and you think what could be happening. So let me show you what would happen. So if you put it across 9 volts, we know the forward voltage of this was what, 1.8 or 1.9 volts, and we're going to put across, say, this is slightly dead, this battery, maybe 8 volts or so. So let's see what will happen. So can you see it's not lighting up green, it's actually got really hot, and I'm not sure if you can see that, but it's producing smoke. And literally within a second of it me touching it, it was glowing red. That's because it got damaged, it got burned out inside. The phosphor coating or whatever that was inside, it's gone. It's that got toasted, and the plastic casing is smoking. The actual lead is really hot. But basically, if you put too much voltage across a diode, that will kill it. So another way to do it, this is junk now, but another way to do it, you can use a higher voltage but put a resistor across. And how to calculate a resistor? Well, you need to know more or less the voltage drop that's going to happen across your diode and your voltage, and it's a really simple thing. Say if you've got a 12 volt supply and you've got a diode that your assumption is maybe let's say 2 volts forward drop. So what you have to subtract one from the other. 12 volts minus 2 volts, we've got 10 volts to limit the current on. And what you want to do is, say, put 1 milliamp through the diode. That means what you need is a resistor in place, and the value, well, what's the current? I equals V over R, right? So with 10 volts, let's say you want to test it with maybe 1 milliamp, which is not 1. What you need is 1001K for 1 volt. We've got 10 volts, we need 10K resistor in order to get 1 milliamp out of it. And you know, anything between 1K and 10K in this matter would do it, and the LED will just light up very, very dimly, because you want to do between 1 and 10 milliamps. Shouldn't damage any LED. Actually, it would work just fine. And what happens when you put combine those two charts together? You have that linear response of a resistor at an angle, and that angle is basically a response. This is actually the resistance over here, and the higher the resistance, the lower that's going to be. So if we draw another one over here, what you get is combination of those two, and it will be like this, more or less. But yeah, with the voltage, it will keep growing more steadily, because over here it shoots up really, really quickly, and that's what kills the LED. But if you limit the current to a few milliamps, maybe 10 milliamps or less, you can check any one of them safely and you won't damage them. Even the high power LEDs, the ones that require 60 volts, they will light up with 5 milliamps easily. They will light up with 1 milliamp very, very dimly. So yeah, this is basically how to do it. Just simply calculate your resistor that you need. That's all there is to it. Quite simple actually, but it's easy to get caught out. If you use a multimeter on ohms range, you're expecting for an LED to actually show something, but it doesn't, and you think it's busted. Well, try with something else. Quick and dirty trick: a button cell battery. It will tell you if it's working. No, it won't tell you what's the forward voltage of it, but if it lights up, you know it's working. So if you're trying to troubleshoot a broken product, go look somewhere else, because this part is clearly operational. Maybe there is a broken track, maybe the driver IC is busted, not too sure. But that's about it for how to quickly check an LED, and why is it easy to damage them with just a battery. Actually, you wouldn't think that this would cause much damage and make something go up in smoke. If you put an LED across 9-volt battery terminals like that, it will die pretty much instantaneously. So yeah, don't do that. Even high power LED, it will go up in smoke no time. So thank you very much for watching. I hope you enjoyed this quick little basics video and you found it informative. If you did, please give me a thumbs up and subscribe for more random electronic stuff. For the time being, take care.